Hello, in this tutorial I'm going to show you how to set up your schematic and instantiate components, place sources, and name nets. Prior to jumping into it, I just want to point out on the Moodle page under Lab 2, I have added some notes which will aid you in Lab 2. And forgive me, the assignment is still named Lab 3. I'll change that. There's some standard resistor and capacitor value tables, and the first video for how to perform a remote login and set up PSpice. So, picking up where we left off last time, which was within our schematic environment, the first thing you're going to notice is I already have the first op amp drawn for figure 1 of the introduction operating amplifiers. This one here, you'll note, looking at the negative and positive terminals, this is the non-inverting configuration. So what I'd like to do at this point is walk you through how to create the schematic for the inverting configuration. Let's see. Starting off with the op amp, we're going to go to place components. We'll go to place PSpice component, and this is a unique component that we're going to have to search for. You could go to discrete and you'll notice that op amps are listed, but the problem is that's an ideal op amp. It assumes infinite gain, bandwidth, input impedance, all the ideal attributes that you'd like to have from an op amp. The op amp that we're going to be using in this lab, which is the LM741, is not an ideal op amp, and we want to take those non-idealities into consideration. So to instantiate this component, you're going to want to go to search, and it's going to launch this window that I already have open over here. Then you're going to come over here, and I'll just clear this out so we act like we're starting from scratch. Type LM741, hit enter, and you're going to want to come down here, double click on the general purpose, and instantiate it into your schematic. So, a couple things to note about components. You'll notice on this one, the positive terminal is on top. Well, unlike the non-inverting case over here. If you'd want to change any of the orientation attributes, you can highlight it by simply one click to select it and pressing the V key to mirror it about the y-axis, the x-axis, or the H key to mirror it about the y-axis. So we're going to leave in this configuration right here. Let's see. The next step is we're going to want to place our sources. So we're going to come over here to place PSpice component, source, voltage sources, and DC. So we're going to put one DC source here, and you're going to notice that there's a positive terminal and a negative terminal on your source, so you want to keep track of those. I'm going to hit the V key to flip it and put another one here. We'll use these for our two sources for the op amp, which are, sorry about that, close this guy out, to page 1, which are our positive 10 and negative 10 sources. Let's see, the next thing we're going to need is resistors. So again, PSpice component, this time we can just come down here. For these labs, we're just going to use ideal resistors. If you wanted to use resistors that you would actually purchase to have placed on a PCB, you could go down to source and search for them. And they come in all different types, through holes and surface mount and whatnot, but I'll leave that to you. So we're going to go with the ideal resistor. Let's see, we're going to put our feedback resistor up here, and we will put our, let's see, input resistor down here. Actually, I'm going to change the orientation of the op amp. We're going to put this one right here, I'm going to turn this resistor off. I'm going to highlight the op amp, select it, hit V. There we go. So now we're going to have our inverting configuration. So the next thing we're going to want to place is our grounds. So we go to place, PSpice component. Now this is a tricky subject here. You want to make sure you have the right grounds for the simulation engine. Now within a schematic, you might have multiple grounds, one for analog, one for digital, one for I/O, but for the simulation engine, which is we're going to be using, it has to have one reference point that it ties all your sources back to, and that is the PSpice ground, which is indicated by the 0 next to the ground symbol. So we're going to put one there and one here, and vertically flip this guy and put one here. And I'm going to shift this down just one for clarity's sake. Okay, now we're ready to connect everything together with what's commonly referred to as nets, which are just wires. To do a wire, I want to point out you can come over here and there's multiple options too. You know, to place a ground, components, nets, name nets, or wires. The one thing I want to point out here is to, like, for instance, draw a wire. You could either click on this button for place wire, or you'll notice when it pops up, it has a W in parentheses next to it. That's an indicator of a hotkey or a shortcut. So you can hit a W. You'll notice it goes to the crosshairs. Now one click ties it to a point. So I'm going to click on the output. Then I can come out. And then if I want to do a 90-degree turn, I click again. I can come up, click again, draw over, then terminate on the resistor node with the final click. So same thing, we'll connect the rest of these up here, come across. And let's see, we're going to come down to connect our feedback resistor. We have our supplies. Okay, connect this to the op amp. And again, it's staying in wire mode the entire time. And that's why you see the crosshairs here. I will show you now, once you're done, if you want to exit the wire mode, you connect it. Say I'm done at this point, I just hit the escape key. So we're going to need one more item, and that is a source to drive our circuit. So these two here are just DC sources. For a signal source, whether it be DC, AC, or transient, I prefer to use a different source on my inputs. So you come down to PSpice component, source, voltage controlled source, and I would select sine. And is it coming? There we go. So hit escape. You'll notice the remote connection can be a little jumpy sometimes. So if it just randomly drops a component down, it's probably a culprit. So again, hit wire and come up, come over. And for this guy, we want all these tied to a ground. Now, I'm not going to go through a demonstration on this, but I will say you do not need to draw multiple grounds in the circuit. You can just have one ground and just name your net names and tie it to it with the appropriate tie points. So the next course of action is we want to name our nets. So we're going to come over here. You have place net alias, or you can just hit N. And I'm going to call this Vout2. And you can change the color, the rotation, and the font as well. Many options in here. Come down there, and you'll see how it highlights the bottom line. Click on that. So that's Vout2. I'll hit escape, and again, and we're going to have VN1. So this will be our, I apologize, we actually want to call that VN2. See, if I call that VN1, it's going to try to tie these two nets together, because it's saying that even though they're not, drawn on the screen connected together, it's saying that these are physically connected together by virtue of having the same name. So to change that, double click on it, you can come up here and just simply change that to VN2. too. Let's see, we have two more nets that we want to name here. We got VP2, which isn't going to work, right? Because this net is actually ground. So we're going to delete that one because it will create a warning. And the last one we're going to create is VS2, which is coming from our source. Okay, now that all the nets are named, we're going to want to go through and change component values or component names or source values. So we'll start off here. This is the positive source. You want to be careful and make sure you look at the V and see the positive. The other thing I want to point out, we'll see this in the lab. These components come in a DIP package with multiple pins, and this symbol has numbers on it here, and that gives you an indication as to what pin in the DIP package is connected to what node. So for example, pin 6 on the DIP package is connected to the output. Okay, so to change the voltage value, we simply double click on the 0 VDC. Just going to enter a 10 in. You don't have to enter the V. And that creates a 10. They're going to come up here. Keep in mind, our negative source has to be at negative 10 volts. Come on. And again, you want to pay attention to the orientation of the source, with the positive being here, and the negative to ground. We want this to drop 10 volts. We have negative 10 here. Let's see, our resistors. We want this one to be at 2K for the feedback. I got 1K here. And again, this goes back to the note hints that I posted on the website for the resistor values. There are multiple resistor values that will provide you with the to meet the gain specifications and the limitation on RA, which would be R1 and R4 in this example. If you wish to change the name of a resistor, you can come in here and change it from R4 to RA, RB, or whatever you so choose. I'm just going to leave them with the numbers for now. Okay, the offset is actually, it's the DC component. It's what we saw in the lab when using the function generator. So for our offset here, I'm just going to start off with an initial value, say, of 6. Amplitude is the actual peak value. Put 0.5. We'll verify that. It could be peak to peak, but I believe it's peak. Frequency, 10K. And AC, we'll just do a magnitude of 1. The differences between frequency and AC will become apparent in the next tutorial I'm going to put together for you when I discuss how to perform simulations. So, at this point, you have now successfully created both of your schematics, and you have all the appropriate components in place, sources, grounds, and so forth. So the last thing you want to do is come up here and click on Save to save it. And this is where we will conclude our lesson. The next lesson will be on how to perform simulations.